Additive manufacturing. Myself, Dr. Suman Das, Professor, Department of Mechanical Engineering, Swami Vivekananda Institute of Science and Technology. So, additive manufacturing, the code is PEME802F. So, in this chapter, we will discuss the molten material system. Now, the molten material system. Molten material systems are characterized by a preheating chamber that raises the material temperature to melting point so that it can flow through a delivery system. The most well-known method is the fuse deposition modeling system, that is called FDM, developed by US company Stratus. Now, this approach uses an extrusion technique to deliver the material through a nozzle in a controlled manner. Two extrusion heads are often used so that support structure can be fabricated from a different material to facilitate part cleanup and removal. Now, the 1D channel approach is very slow in comparison with other method. The thermojet from 3D system also deposit a wax material through droplet based printing heads. The thermojet approach, however, is not widely used because wax material are different and fragile when handled. Thermojet machines are no longer being made, although existing machines are commonly used for investment casting patterns. Now the fuse deposition modeling, that is FDM, that is called molten material system. Now what is the principle? The principle of FDM is based on surface chemistry, thermal energy and layer manufacturing technology. The material is filament, that is called spool, from a melted in a specially designed head which extrude on the model. As it is extruded, it is cooled with and thus solidifies to form the model. The model is built layer by layer like the RP system, that is rapid prototype system. So if you see the diagram, this is the picture. With the help of this picture, so this is the base form base and build platform, and this is the build material spool, and so that is coming through this, and this one the part is prepared manufactured, and there are support material. This is the support material and this is the build material. Now what is the process? Now I am explaining the process in step by step. A geometric model of conceptual design is created on a CAD software, which is STL formatted file. Already I have explained in my previous discussion, previous slide and previous lecture. It is then imported into the workstation where it is processed through a quick slice support work software. Within the software, the CAD file is sliced into the horizontal layer after the part is oriented for the optimum build position, and any necessary support structure are automatically detected and generated. The slice thickness can set manually to anywhere between 0.172 to 0.356 millimeter depending on the needs of the model. tool paths of the build process are then generated, which downloaded the FDM machines. Now, the modeling material is in spool very much like a finish line. The filament on the spool is fed into a extrusion head and heated in a semi-liquid state. The semi-liquid material is extruded through the head and then deposited in a ultra thin layer from the FDM head, one layer at a time. The air surrounding the head is maintained at a temperature below the material melting point. The existing material quickly solidifies. And moving on the XY plane, the head follows the follows the tool path generated and quick slice generating the desired layer. After that, when the layer is completed, the head moves on to create the next layer. The horizontal width of the extruded material can vary between 0.250 to 0.965 millimeter depending on the model. This feature called road width can vary from slice to slice. Two modular material are dispensed through a dual tip mechanism in the FDM machine. Now, this is the diagram. A primary modular material is used to produce the model geometry and the secondary material or release material is used to produce the support structure. So this is the support material and this is the build pool. So the build pool is coming through this build material spool and this is the build material and the green color that is the support material. So this is the extrusion nozzle and this on the parts and this is the supports and this on the build platform. This build platform is gradually comes down. The release material forms a bond with the primary modular material and can be washed away upon completion of the 3D model. So if you see the diagram, so from this diagram, it will be very clear that this is the support, the red color is the support material and this is the build material. This is the animated picture, how the 3D model is generated. Now the application. The application part is the models of the conceptual and presentation. Models are used for the conceptualization and presentation, prototype for design, analysis and functional testing, and that patterns and masters for tooling. So these are also used for patterns and the master for tooling. Thank you. Thank you very much.